We wanted to give a presentation today on the data protection workflows white paper that was put out by the Kubernetes Data Protection Working Group. I'm Dave Smith-Uchida. I'm from Caston. I'm a member of the working group. And joining me is also Xing Yang. You can introduce yourself.
Hello, everyone. My name is Xing Yang. I work at VMware in the cloud storage team. I'm also a co-chair of CNCF Task Storage, a co-chair of Kubernetes SIG Storage, and a co-chair of the Data Protection Working Group in Kubernetes.
Unfortunately, neither of us could be here in person today, but we'll go through this by video. So the Data Protection Working Group has pretty broad membership across the Kubernetes community, and the white paper had a number of authors across a broad spectrum of companies, storage vendors, application vendors such as Mongo, and data protection vendors. So when we talk about data protection with Kubernetes, sometimes we get the question like, what is data protection? So the data protection that we're talking about is really the protection of data in terms of disaster recovery, so that we can back up and restore an application to a previous state. So in the event that the data gets corrupted, or that we have some kind of a disaster where the data is lost. Now, applications in Kubernetes are complex. This has made it a lot more challenging to do backup than we've done previously with things like file systems and virtual machines. So at the moment with Kubernetes, the backup and recovery is mainly around two things. One is the API resources, because in order to bring the application back to a working state, we have to put the API resources back so that pods, load balancers, et cetera, get recreated, and data in persistent volumes. So that's where we're at the moment. And it's a difficult problem, because there's a lot of things that have to be coordinated together, both during the backup phase and even more importantly during the restore phase, to get a working application running again. So, who needs data protection? Why do they need it? So, originally Kubernetes apps were typically stateless. They might be running something like a scale out load balancer in Kubernetes. If it goes down, it goes down. You reapply the YAMLs, it comes back up, you're happy. But we were running stateful applications in Kubernetes. And the data, it may have data stored in persistent volumes that's important. You may have a database running. You can have files being stored in there. Have an object store even running in your Kubernetes application that's storing things. And the other thing that's actually becoming more common, and something that people really need to be aware of, is that applications are storing state in the API server. So we have custom resources that are being created and config maps, et cetera, that the application is using to store its state in. And if you lose that state and you just reapply, even if you don't have any data in persistent volumes, if you reapply the YAMLs and your application was actually keeping track of some state in the API server, it's going to go back to an initial state, not to where you were at when you were running. And most applications are actually combining the two. They have data in persistent volumes and state stored in the API server. So that's why we believe that people need it in Kubernetes. And cloud native apps take a different approach to data protection, because we have a distributed system. So that's another challenge. We have dozens, hundreds of pods, hundreds of persistent volumes. It's a much more complicated system than it was previously. Another challenge is that the user roles are changing. So we've got more and more people moving towards DevOps, where we actually have both the developer and the operation roles are merged together. And that means that it's no longer a matter of making an application and then turning it over to the ops team. Really, because the backup and restore becomes more complicated, and the developer team is often responsible for at least some of the operation, developers need to be more aware of data protection, and sometimes they need to run it themselves. So when we were looking at user personas, this is something that we cover in the white paper, is we came up with three different major ones here. One are the application owners. These are the people, basically the development team, but also the DevOps team that is there creating and running applications. Now, in many organizations, we also have a central operations team or backup team that's also responsible for making sure that applications are backed up. There may be a corporate policy that says, hey, everything needs to be backed up daily. We need to be able to recover within this amount of time. We have RTO and RPO objectives. That team needs to be able to make sure that all of the applications, including the Kubernetes applications, meet those practices and compliance with the regulations. Then we have the Kubernetes admins who are primarily concerned with making the cluster, keeping the cluster running so they can run applications. So those are the three personas we've identified. Now, in terms of, what are the use cases for data protection? Four of the major ones are going to be disaster recovery. That is that we actually had some form of a disaster. So we may have had a loss of hardware. We may have, primary storage may have gone down. We may have lost a data center. Rollback is another valid use case. That is, we've made a software update that didn't go right, and we need to get back to a previous version, or we applied some kind of change to the database that didn't go right. We want to roll back. Another good use case for, it's not really data protection, but it overlaps a lot because it's almost the same mechanism, is migration. We want to move an application from one cluster to another. And then very similar to this is cloning, where we have the application is running and we want to make another version of it, either to scale out, or we may want to do it for testing. We bring it up for a while. And then, so we want to be able to copy the application. I'm going to turn it back over to Xing, and she's going to go through the remainder of the presentation, starting with the components.
Thanks, Dave. So this diagram shows the backup workflow with existing and missing building blocks in Kubernetes. This diagram is color-coded. Blue shows the backup process, and green shows the existing Kubernetes components. Yellow shows work in progress Kubernetes components. Orange shows missing Kubernetes components. For an application backup, we need to back up Kubernetes resources and data. For data backup, we could either use the native data dump or controller coordinated. For controller coordinated, we first quiesce application, then we take a volume snapshot, then we unquiesce the application. And then we export the backup to a backup repository. As shown here, existing building blocks include volume snapshot and workloads APIs, such as stateful set, deployment, and so on. Work in progress building blocks include container notifier and cozy. And there are also missing building blocks, such as application backup. Next slide, please. Similarly, this diagram shows the restore workflow with existing and missing building blocks in Kubernetes. For an application restore, we first import the backup. We need to restore Kubernetes resources. We also need to restore PVC and PV. If it's a native method, then we restore from native data dump. Otherwise, we rehydrate PVC from volume snapshot. Next slide, please. We talked about what are the existing building blocks and what are the missing building blocks in supporting data protection in Kubernetes. Now let's see what we are working on in the data protection working group to fill those gaps. The first one I want to talk about is the volume populator. Without a volume populator, we can only create a PVC for another PVC or from a volume snapshot. But what if the backed up data is stored in a backup repository, such as an object store? The volume populator feature allows us to provision the PVC from an external data source, such as a backup repository. In addition, it allows us to dynamically provision a PVC, having data populated from that backup repository, and honor the wait for first consumer volume binding mode during restore to ensure that volume is placed at the right node where pod is scheduled. This feature moved to beta in 1.24 release. The next one I want to talk about is this new alpha feature, control volume mode conversion. Without this feature, it is possible for anyone to create a PVC from a volume snapshot with a volume mode that is different from the original one. This could lead to a potential security issue even there is a CVE in the kernel. On the other hand, converting the volume mode from file system to block when creating a PVC from a volume snapshot is being used by backup vendors for more efficient backups. So we introduced this alpha feature that allows Kubernetes to check whether the user has permission to convert the volume mode. If not, reject the request. This way we can support this valid use case only for authorized users. This feature is alpha in 1.24 release. And the next feature I want to mention is change block tracking, CBT. This is a feature that the data protection working group is actively working on. This is a feature that identifies blocks of data that have changed. It enables incremental backups to identify changes from the previous backup, running on each changed blocks. Without CBT, backup vendors have to do full backups all the time. This is not space efficient, takes longer time to complete, and needs more bandwidth. We have been doing POC for this feature. Design is in progress. We are targeting alpha in 1.25 release. The next feature I want to talk about is COSI, Container Object Storage Interface. COSI proposes object storage Kubernetes APIs to support orchestration of object store operations for Kubernetes workloads. It also introduces gRPC interfaces for object storage providers to write drivers to provision buckets. COSI components include a COSI controller manager that binds COSI created buckets to bucket claims, a COSI sidecar that watches COSI Kubernetes API objects and calls COSI driver, a COSI driver that implements a gRPC interfaces to provision buckets. We are trying to target alpha in 1.25 release. And the next one is container notifier. This is for quiesce and unquiesce hooks. We need these hooks to quiesce application before taking a snapshot and unquiesce afterwards to ensure application consistency. We investigated how quiesce, unquiesce works in different types of workloads. They have different semantics. We want to design a generic mechanism to run commands in containers. But if we want to mention that application-specific semantics is out of scope. We currently have a proposal called Container Notifier. CAP is submitted and it is being reviewed. We talked about Container Notifier proposal, which tries to ensure application consistency. What if you can't quiesce the application, or if the application quiesce is too expensive, so you want to do it less frequently, but still want to be able to take a crash consistent snapshot more frequently? Also, an application may require the snapshots from multiple volumes to be taken at the same point in time. That's when consistent group snapshot comes into the picture. There's a cap on volume group and group snapshot. It proposes to introduce a new volume group CRD that groups multiple volumes together, and a new group snapshot CRD that supports taking a snapshot of all volumes in the group to ensure write order consistency. The cap is currently being reviewed. We have snapshot APIs for individual volumes, but what about protecting a stable application? There's a CAP submitted that proposes a Kubernetes API that defines the notion of stable applications and defines how to run operations on those stable applications, such as snapshot, backup, and restore. This is still in very early design stage. So these are all the features I want to talk about that we are working on in the data protection working group. Next slide, please. I think we have the how to get involved. Okay, so we have this homepage for our data protection working group. It has a lot of information on how to get involved in data protection working group. We have bi-weekly meetings on Wednesdays at 9 a.m. Pacific time. Previous meeting recordings are available on YouTube. You can also add items you want to discuss in our meeting in the agenda doc. We have a mailing list, so join our mailing list so that you can get invites to the meetings. We also have a Slack channel for communications. That's all we have today. Thank you all for attending. If you are interested in learning more, please join our working group. Bye-bye.
Thank you for coming. Sorry we can't be there.